Here we are on section 7.6. We're doing questions from the part 43 through 50. And as I said yesterday, these are probably the type of questions that will be the extra credit problem. These are the toughest tough questions. So let's see if we can do our best. Let's start at question 44. We have the radicals on both sides, so I'm going to square both sides. Notice when I square both sides, this negative comes in the parenthesis there. When I square, I'm going to be binomial times binomial. That's what it means to square. So I'm going to rewrite it as two binomials. And on this side, this is like a -1 out there. -1 squared is +1. Square root of this just goes away. And so over here, I'm going to FOIL. The square root of 2x minus 1 times the square root of 2x minus 1 just gives me 2x minus 1. Outside times outside gives me -4 times 2x minus 1. Inside times inside is -4 times 2x minus 1. And last times last, -4 times -4 gives me 16. Let's put some like terms together. I have a 2x, -1, and +16. They're on the same side, so I add them together. It gives me 15. -4 and -4 gives me -8 square roots of 2x minus 1. And then I'm going to subtract 2x from both sides. I'm going to subtract 15 from both sides. And I get -8 square roots of 2x minus 1 equals -x minus 19. All right. Before I move forward, you notice that this term is negative, that term's negative, that term's negative. So as you know, we can multiply the entire equation by -1 and just change everything to positive. Not that it's a big deal, but most of the time people make a lot of mistakes on negatives, and this will probably cut down on some mistakes. Then I'm going to square everything. I can get 8 squared is 64 times the quantity of 2x minus 1. Over here, squaring the binomial is like multiplying it by itself. If I take x times x, I get x squared. Outside times outside is 19x. Inside times inside is 19x. Last times last. 19 times 19 is 300. Somebody's going to have to help me here. 381 or 361? 361. Thank you. Then let's distribute, and I get 128x minus 64 equals x squared plus 38x plus 361. If I minus 128x minus 128x plus 64 plus 64, I get 0 equals x squared minus 90x, and that gives me 425. So we are looking for the factors of 425 that add up to -90. So there are going to be two negative numbers. So I'm going to say, well, what is this? This is 5 times what? What's 425 divided by 5? Do I get 81? 85? 81? 85. So how about -5 and -85? Because that would multiply to give me that. And so I get x minus 5 and x minus 85 equals 0. So my two answers are going to be 5 and 85. Now here's where we start talking about extraneous roots. If I plug 85 back into the original question, if I take 2 times 85, I get 170. 170 minus 1 is 169. Square root of 169 is 13. 13 minus 4 is 9. If I take 85, 85 minus 4 is 81. Square root of 81 is 9. Negative 1 that's in front of there gives me a negative 9. Is 9 equal to negative 9? No. So we know that this, even though it says it's an answer, we have to cross it off because that's an extraneous root. If we plug in 5, it works out. 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is 3. 3 minus 4 is negative 1. 5 minus 4 is 1. Square root of 1 is 1. 1 times negative 1 is negative 1. So negative 1 equals negative 1 is a true statement. So we know that this is not an extraneous root. Let's take a look at the next one. Number 8, 47. 47, I have the square root of 3x plus 4 minus 1 equals the square root of 2x plus 1. Again, we have the radicals already split, so we're going to square it, which gives me 3x plus 4 minus 1 times 3x plus 4. Make sure it's under the radical. Minus 1 equals square root 2x plus 1 squared. When I FOIL this out, I get 3x plus 4 minus the square root of 3x plus 4 minus the square root of 3x plus 4, and negative 1 times negative 1 is positive 1. Make sure your radical covers everything. On the other side, I get 2x plus 1. Again, let's put our like terms together. I'm going to have 3x plus 5 and minus 2 square roots of 3x plus 4 equals 2x plus 1 minus the 3x minus the 3x minus the 5 minus the 5. And I get negative 2 square roots of 3x plus 4 equals negative x minus 4. Again, notice everything's negative. We certainly can. You don't have to at this point, but you certainly can change the signs before you multiply it out. We just want to avoid as many mistakes as we can. So then here we are to the second squaring of everything. Notice that I left this 2 in front of here. I do that. You certainly could divide by it and then square this side, but you can leave it in front if you know how to handle it. 2 squared is 4. I'm kind of doing it just to make sure you've seen how to do it the right way. The square root and square are opposite operations, so then you put a parenthesis there. On this side, foiling, I get x squared plus 4x plus 4x plus 16. Distribute 12x plus 16. I'm going to minus 12x from both sides. I'm going to minus 16 from both sides. So on the left side, I get 0 because I subtracted off both of those. On this side, I get x squared. 4x is 8. 8 minus 12 is negative 4. And we get 16 minus 16 goes away. Factoring out my greatest common factor because my number term went away, so I'm going to factor out an x, leaving me with x minus 4. And my two answers are going to be 0 and 4. Again, we would want to check both of those, and I've checked both of them, and they are both good roots. Neither one of them go away. All right. Let's take a look at 48. 48, same kind of deal. This one gets a little uglier because you get a yucky quadratic that you have to factor. This is probably the hardest one of the bunch. Most likely something like this will be your extra credit question on your test. So one that you're going to end up having to factor quadratic. So this would be a good one to star in your notes. And on this side we have 4x plus 1 squared. Let's FOIL this side out. We get x minus 2. Outside times outside gives me 3 square roots of x minus 2. Inside times inside gives me 3 square roots of x minus 2. And then last times last, 3 times 3 gives me 9. On this side, the square root, square are opposite operations. So the square root and the square just go away. Let's put our like terms together. I have an x, negative 2 and 9 gives me positive 7. 3 and 3 gives me 6 of these radicals. Let's minus my x and minus my 7, minus my x and my 7. On this side I get 6 square roots of x minus 2. On this side I get 3x minus 6. Now again, at this point, if we can simplify anything, we should. You notice 6, 3, and 6 are all divisible by 3, so I'm going to simplify before I square both sides here. Dividing everything by 3, I get 2 times the quantity of x minus 2 equals x minus 2. It's a little bit simpler than this. Certainly, if you'd have squared this and factored it out, you would have got the same answer as I am. Again, this time I'm going to divide by this 2 just to show you what the other method doesn't matter either way. I'm just showing you both ways. You guys can pick which way you like. I'm going to square this side, square this side. So on the left I get x minus 2. On this side I get x squared minus 2x minus 2x plus 4 all over 4. And then I'm going to multiply both sides by 4. You see why I've been leaving it on the other side, because then you end up multiplying it back over there to get rid of the fraction. We don't like fractions, right? So I get 4x minus 8 equals x squared minus 4x plus 4. Now I'm going to minus the 4x minus the 4x plus the 8 plus the 8. And I get 0 equals x squared minus 8x plus 12. So we're looking for factors of 12 that add up to negative 8, which is my negative 6 and negative 2. So I'm going to factor that into x minus 6 and x minus 2. So my zeros are at 6 and 2. And we certainly could check these for extraneous roots. I've already done that, and they both work. So they're both good roots. So no extraneous roots on that one. And let's go to number 49. Y plus 3 minus y minus 3 equals 1. We're going to have to split these, so I'm going to add square root of y minus 3 to both sides. That goes away. So I'm going to square both sides, so I get square root of y plus 3 squared. On the other side, squaring the binomial means to multiply it by itself. This side, square root, square, opposite operations, they just go away. This side we need to FOIL 1 times 1 plus 1 times the square root plus 1 times the square root. And then square root times square root gives me y minus 3. So here, if we put our like terms together, 1 and negative 3 gives me negative 2 plus y. If we have one of these and one of these, that makes two of them. So plus the 2, minus the y, minus the y. This is the nicer case where your variable on this side goes away and you're left with just a number. We like that. And we get 2 square roots of y. And all of a sudden, it's not working. Okay, I think we're back. And 2 square roots of y minus 3. Again, there's two ways we can deal with this coefficient. You can square it, leaving it over there, or we can move it over there before we square it. I'm going to leave it over here again. Squared, squared, I get 25 equals 2 squared is 4. Square root squared, opposite operations, comes out in a parenthesis. Distribute 4y minus 12, add the 12, add the 12. I get 37 equals 4y. Divide by the 4. So I get 37 fourths. And you would want to check for extraneous root on that one. It works. 50. Last one here, we have the square root of x plus 1 minus the square root of x minus 1 equals 2. Let's move this to the other side. So I would have plus the square root of x minus 1. So this side just looks like that. Square it. Square it means to multiply by itself. Over here, square root, square, opposite operations, they just go away. Over here, foiling, I get 2 plus 2 square roots x minus 1 plus 2 square roots x minus 1, and then plus x minus 1. Minus the x, that's nice. Here I get 2 minus 1 is 1, so I'm going to subtract 1 from both sides. And so I get 0 equals 2 square roots of x minus 1. Is it okay to equal 0? Yeah. Dividing by 2, I still get a 0. And so I get square root x minus 1. Square this side, square this side. I get 0 equals x minus 1. So I get add 1, I get 1. So 1 equals x. Now here's where people get excited, especially because it's the last question of the assignment. They get done, they don't want to check for extraneous roots. If we put it back into the original question was minus equals 2. If I put it in here, we had 1. 1 plus 1 square root gives me the square root of 2. 1 minus 1 gives me 0. So I have the square root of 2 equals 2. Is that a true statement? So the one answer we get doesn't work, so the answer is no solution. We go all the way through, get our answer, try it, and it doesn't work. There's your assignment, and good luck to you.